For 4c, we're given the origin 0, or rather O, at the point 0, 0, 0. And we want to find the value for P when the airplane is closest to 0. This is a closest distance problem, and so what we need to do is we need to take the dot product between two vectors. Let's kind of visualize what's going on here. We have the origin at 0, and we have this plane. Let's call it A for airplane. It's moving in some direction. So it looks, who knows if it looks anything like this, but this is just a representation. And what I'm interested in is when the vector from O to A is perpendicular. So A is moving in this direction. The direction of this vector A is one of the vectors that I want to compare or take the dot product of. So I need this direction vector, -2, 3, 1. -2, 3, 1. That is the direction vector, velocity vector of this airplane. And I want to dot it with the vector from O to A. Now A is moving along this path over time. And so I really want to find the vector from O to A. And I want to set this dot product equal to 0. This vector OA changes as A is moving. And so that's why I'm going to have to end up solving for P. So let's see how that plays out. Let's find what vector OA is equal to. OA is how I get from the point O to the position A. And I could think about the position vector from this equation for A. And really what I'm going to do is I'm going to subtract the position vector A minus the position vector of O to find vector OA. So let's do that. Let's take A, and A is going to be given by 3 minus 2p, and -4 plus 3p, and 0 plus p. This is the point A. A is moving based upon this vector equation, and I can just kind of combine that into one position vector. We'll subtract 0, subtract 0, subtract 0, since the position vector of O is 0, 0, 0. And I want to dot that with the directional vector -2, 3, 1, and set it equal to 0. So what that gives me is -2 times 3 minus 2p plus 3 times -4 plus 3p, and then plus 1 times p, or just p, and that's all equal to 0. So let's multiply this out, and I'll get -6 plus 4p minus 12 plus 9p plus p equals 0. Let's combine our like terms, and we'll get -18 plus, that looks like 14p equals 0, or 14p equals 18. If I divide both sides by 14, I get p equals 18 over 4, which is equal to 9/7. And that's, I believe we're talking about seconds here. So 9/7 seconds is the value for p when that airplane is closest to the origin. So it takes 9/7 seconds for it to reach this point here. So that's number 1. Now we want to figure out how to do this number 2. And this says, hence, find the position of the plane closest to the origin. So I just found this time value that puts my plane right here. And so now I need to figure out what this position vector is right here for that plane. And to do that, I can just use this vector equation, or I can use the position vector of the airplane A. So let's take the vector equation. So this is 3, -4, 0, plus the p-value is 9/7, and that's times -2, 3, 1. Let's evaluate what this is. So this is 3 plus 9/7 times -2, or -18/7, and -4 plus, this will be 27/7. That's my y component, and my z component is 0 plus 9/7. So this will all equal, let's simplify this into one position vector. This will be 21/7, and so that when I add them up, I should get -3/7. This is -28/7. When I add those two up, I get -1/7, and when I add these two, that's just 9/7. So that's my position vector of the plane, but I'm asked to find just the position of the plane, so the last thing I need to do is write this as a coordinate. So the x coordinate, or the x value for the coordinate, is -3/7, the y is -1/7, and the z is 9/7. So this here is the position of the plane at 9/7 seconds, which is when the plane is closest to the origin.